Hello everyone, my name is Satyanarayan and today we are going to take a look at a simple topic in mathematics called probability. So what exactly do we mean by probability? Well, simply put, it is the chance of occurrence of an event. Many times we ask questions like what is the chance that it will rain tonight? Or what is the chance that India will win its next cricket match? Or more importantly, what is the chance that I'll clear my entrance exam? Well, the answer to all these questions can be mathematically calculated, and this is where the math of probability comes into picture. So there's one simple basic formula in probability which will help us understand and solve most of the questions. The probability of an event n is given by the ratio of the number of favorable outcomes to the total number of possible outcomes. Now, what do we mean by an event? Well, some basic types of events that we have questions on in competitive exams include the tossing of a coin, or the throwing of a die, or the picking of cards or balls from a bag. So an event is simply that about whose probability you wish to know. So let us take an example and understand this basic concept. The most simple kind of question which can be asked in an exam is related to the tossing of a coin. Now, we know that a coin has two sides. On one side we have the heads, while on the other side we have the tails. So when we toss the coin, either we have the heads or the tails as an outcome. Before we proceed, let us simply understand that the only two outcomes which can come when you toss a coin is either heads or tails. We will be using a fair coin and not like the one in the movie Sholay which had heads on both sides. That would be cheating, right? Similarly, remember, if we toss a coin, it will definitely land on either one of its two sides. It will not keep standing in the middle as it happens in a lot of Hindi movies. So remember, when we toss a single coin, there are only two total outcomes possible, which are either a heads or a tails. So if I ask what is the probability of the coin showing a heads, then we already have seen that the formula for the probability is the number of favorable outcomes divided by the total number of possible outcomes. In a single coin, there are only two possible outcomes, out of which we require only the heads. So there is only one outcome which is favorable to us, and hence the probability of heads is calculated as 1 by 2. Similarly, the probability of tails when we toss a single fair coin is again the total number of outcomes is 2, which goes in the denominator, and out of the two possible events only one of them is favorable to us, and hence the probability of tails again is 1 by 2. As we can see here, the probability of heads plus the probability of tails adds up to 1 by 2 plus 1 by 2, which is equal to 1. So when the sum of two probabilities for an event adds up to 1, it indicates that there is no other possibility of an outcome. Heads and tails are the only two outcomes which can possibly come when we toss a fair coin. From this discussion, we can also understand that the lowest probability of any event would be 0. So the lowest probability is 0 and the highest probability of an event is 1. So the value of the probability of an event occurring lies between the values of 0 and 1. Converting into percentages, the lowest percentage value of an outcome is 0% and the highest possible outcome is 100%. If the value of the probability of an event is 0 or 0%, it means it is an impossible event. That outcome can never occur. Similarly, if the probability of an event has the value 1 or 100%, it means it is a sure event. That event will occur. So we have various questions on tossing of coins. Starting with the first one, which we've already seen. What is the probability of getting a single head on tossing a single coin? So the probability of a single head, we have two possible outcomes in the denominator, and out of these two outcomes only one, that is the heads, is favorable, and hence the probability of getting a single head on tossing one coin is given by the formula 1 by 2. Now the second question asks, what is the probability of getting at least one head on tossing two coins? Now remember, if one single event has two outcomes, then repeating the event twice gives me 2 to the power 2, which is 4 outcomes. That means 2 outcomes for the first event and 2 outcomes for the second event. So 2 multiplied by 2 or 2 raised to the power 2 gives me 4. Now what are these 4 possibilities? Either we can have both the coins showing heads, or the first one shows a heads and the second shows a tail, or the first shows a tail and the second shows a head, or both of these events show tails. So the probability of this has the denominator value 4. Now the question asks, what is the probability of getting at least one head? That means 2 heads would satisfy the condition, 1 head out of 2 does satisfy, similarly 1 head out of 2 satisfies. This is the only outcome which is not favorable, which means there are 3 favorable outcomes out of a total possibility of 4, and hence the probability of at least one heads on tossing 2 coins is given by 3 by 4. Now, the question asked is, what is the probability of getting exactly one head on tossing 2 coins? As we have already seen, the 4 possible outcomes when we toss 2 coins can be 2 heads, heads and tails, tails and heads, tails and tails. So the denominator is 4. Now, I need exactly one head, which means I cannot have 2 heads, I can have 0 heads. There are 2 outcomes which have exactly one head each. So the probability of this occurring is 2 by 4, or in reduced form, it's 1 by 2. Now, what is the probability of getting at least one head on tossing 3 coins? The total number of outcomes possible in this case is the multiplication of the number of outcomes per event. As a single coin can have 2 outcomes, 3 coins can have 2 to the power 3, which is equal to 8 total outcomes. So the answer's denominator value is 8. Now, if we try to list down all the 8 occurrences, those would include heads, 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 heads and tails, heads, tails and heads, tails, heads and heads, heads, tails and tails, tails, heads and tails, tails, tails and heads, and tails, tails and tails. So these are the 8 outcomes. I need to include all those outcomes which have at least one head. So 1, 2, 3, 4, 5, 6 and 7 of these outcomes have at least one head in their configuration, and it's only one of these outcomes, that is all tails, which does not give me the required condition. So the probability of getting at least one head on tossing 3 coins is 7 by 8. There's an alternative method of doing this problem. The opposite of at least one head being there on the 3 coins is there is no heads on the 3 coins. Now, if there are 3 coins, there is only one way in which all the 3 show tails, and that is tails, tails, tails. So the probability of getting all tails is 1 by 8. So the probability of getting at least one head can be taken as the total probability 1 minus the probability of getting all tails, and that is 1 minus 1 by 8, which again works out to be 7 by 8, our original number. The second kind of question which can be asked are the questions which involve the throw of a dice. Now, as with coins, we assume that this is a fair dice and the probability of any one of the faces landing up is the same. Now, a dice is nothing but a cube which has 6 faces, and each of these faces is marked from the numbers 1 to 6. So the probability of getting any one of these numbers is exactly the same. So if I were to ask what is the probability of getting the number 3, then from the 6 total outcomes, one of these numbers satisfies my condition. So the answer is 1 by 6. Let us take a look at a few questions on how to solve questions on dice. So what is the probability of having the number 5 showing up when I'm throwing a single die? For this, I know that there are 6 possible outcomes for a single die, and the number 5 is one of those 6 possible outcomes. So the answer here is 6. What is the probability of getting an even number on throwing a single die? Again, on a single die, there are 6 total outcomes possible. Out of the numbers 1 to 6, the numbers 2, 4 and 6 satisfy the condition, and the numbers 2, 4 and 6 are 3. So 3 numbers out of 6 will help me satisfy the condition, and hence the answer is 3 by 6 reduced to 1 by 2. What is the probability of getting the number 3 or 5 on throwing a single die? Again, for a single die, the total number of possible outcomes is 6. I need either 3 or 5. So any of the two numbers, 3 or 5, out of the total 6 numbers are favorable for me. So the answer is 2 by 6 reduced to 1 by 3. Now here is an interesting question. What is the probability that the product of the number shown on the two dice is even on throwing two dice? We have two dice and we have the numbers 1 to 6 which can show up on the two dice. What this question says is, supposing the number 2 shows up on the first die and 3 shows up on the second die. We multiply these two numbers 2 and 3 and take 6, which is an even number. But if the number 3 shows up on one of the dice and the number 5 shows up on the second dice, then 3 multiplied by 5 would give me 15, which is an odd number. So all in all, what is the product of the number shown on the two dice? Or rather, what is the probability that the product of the number shown on the two dice is even? So first of all, we get there are two dice. On one die, 6 total outcomes. So 6 multiplied by 6, there will be a total possibility of having 36 different outcomes. Out of these 36 outcomes, how many of them would be favorable to us? Well, if we take into consideration that there are exactly 3 even and 3 odd numbers in this, then we know that odd multiplied by odd gives me an odd number, odd multiplied by even gives me an even outcome, and even multiplied by an odd again gives me an even outcome, and an even multiplied by even again gives me an even outcome. So there are 4 different combinations possible, which means the outcome can be any one of these 4, and out of which 1, 2 and 3 such outcomes are even, which are favorable to me. So the answer here can be 3 by 4. Alternatively, we can work out all the combinations possible. The first die can have any of the numbers 1, 2, 3, 4, 5 and 6. Similarly, the second die can be any one of the numbers 1, 2, 3, 4, 5 and 6. Now any number multiplied by 2 would give me an even number. So I have these 6 possibilities. Similarly, any number multiplied by 4 also gives me an even number, and any number multiplied by 6 also gives me an even number. Similarly, if the other die gives me the 2 or the 4 or the 6, then my product becomes even. So if I simply calculate or count these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 and 27. That means 27 of the outcomes out of a total possibility of 36 are even, and 27 divided by 36 when reduced again gives me the answer 3 by 4. So the probability that the product of the number shown on the two dice is even on throwing the two dice is simply 3 by 4 or 75%. Now the question asked is, what is the probability that the product of the number shown on the two dice is a multiple of either of 3 when we throw the two dice? So the simplest way to do this is to create the table. So die 1 could have any one of the 6 outcomes 1, 2, 3, 4, 5, 6, and similarly the second die could have the 6 outcomes from 1, 2, 3, 4, 5 and 6. Now the question asked is that the product has to be a multiple of 3, which means if there is a number 3 on any one of the dice, then the product of the two numbers is obviously a multiple of 3. Similarly, if the number 6 shows up on one of the two dice, even then the product of the two number automatically becomes a multiple of 3. So 3 multiplied by any of the number makes the product multiple of 3. 6 multiplied by any number makes it a product multiple of 3. Similarly for 3 on the other dice and 6 on the other dice. So the total number of outcomes possible is 36, out of which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20 numbers are those which are multiples of 3. So when I reduce this, I get 4 5s are 20 and 4 9s are 36. So the probability that the product of the number shown on the two dice is a multiple of 3 is 5 by 9. A typical question which can be asked in the paper is based on the playing cards. Now we know that a standard deck of playing cards has 52 cards in it. We do not count the jokers or the blank cards. There are two distinct colors, black and red, which make up all the cards. In black, we have two suits. One which looks something like this, called the spades, and the other which looks something like this, called the clover or clubs. In the color red, we have two suits, the hearts and the diamonds. So in all, there are 4 suits in a standard pack. Each suit consists of 13 cards each. So 13 multiplied by 4 gives me total of 52 cards. Each 13 card contains 10 cards from the numbers 1 to 10, and the remaining 3 cards are called face cards, which include the jack, the queen and the king. So per suit we have 10 ordinary cards and 3 face cards, which gives me a total of 12 face cards in the entire pack and 40 ordinary cards. Now, typical questions involve what is the probability of getting a particular set of cards. So now what are the chances of getting a spades when one card is picked from a standard deck? Well, a standard deck has 52 cards. So when I pick a card, any one of these 52 is an outcome. And my favorable cards are those which are the spades. And as we know, there are 13 cards per suit. So there are 13 spades in the pack. So my probability of getting a spade when a single card is picked from the standard deck is 13 by 52, which works out to 1 by 4. What are the chances of getting an ace when the first card is picked from a standard deck? So again, I know that there are 52 cards, the total number of outcome, that is the denominator, and there are 4 aces in the pack, one from each suit. As I have to pick just one ace, any one of these 4 aces would be sufficient. So the probability of picking an ace when a single card is picked from the standard deck is 1 by 13. What are the chances of getting the ace of spades when a single card is picked from a standard deck? Well, a standard deck will have a total of 52 cards, and presuming there is no cheating involved, there is only a single ace of spades in the entire deck. So that single card is the only favorable one. And hence, the chances of getting the ace of spades when you pick a single card at random from a deck is 1 by 52. Now, what are the chances of getting an ace as the first card, the king as the second card, and the queen as the third card when 3 cards are dealt one after another from a single deck? Well, so here I calculate the probability of the first card being an ace and the probability of the second card being a king and the probability of the third card being a queen. Now, initially the entire deck of 52 cards is available to me, and from that the probability of getting an ace is there are 4 aces in the deck. So the probability of the first card being an ace is 4 by 52. Now, as the first card has already been selected, I have got only 51 cards left to select from. But here again, I need to pick up the king, and there are 4 kings left in the pack. So the probability of the second card being a king is now 4 by 51. Now, as one more card has been removed, the total cards left in the pack is 50. And now there are 4 queens left in the deck for me to select from favorably. And hence, the probability of getting the queen as the third card is 4 by 50. So the total probability works out to 4 multiplied by 4 multiplied by 4, the whole divided by 52 into 51 into 50. Now, a slight variation on this example. What are the chances of getting an ace as the first card, the king as the second card, and the queen as the third card, provided all 3 of the cards have to be from the same suit? So again, I need to calculate the probability of the first being an ace, the second being the king, and the third being the queen. There are 52 total cards, out of which any one of the 4 aces will satisfy me, and the probability of the first card hence is 4 by 52. However, now for the second card, the total number of cards is 51. Here the condition is that I have to pick a king and the king must be of the same suit as the ace. So whichever ace I pick, there will be exactly one king in the pack which is of the same suit as the ace, and that gives me 1 by 51 as the probability of that king. Similarly, there are 50 cards left, but there will be only one queen which is of the same suit as the ace and the king previously selected. So in this example, the probability of getting the ace as the first card, king as the second, and queen as the third, with all three of them being of the same suit, is 4 into 1 into 1 divided by 52 into 51 into 50. The final kind of example which can be asked in the exam is picking of colored balls. So assume that there are 6 red, 7 blue and 8 green balls. Then what are the chances that if 2 balls are picked one after the another without replacing the ball back in the bag, then both the balls picked are red? Now I have 6 red, 7 blue and 8 green, which means the total number of balls in the bag is 21. Now the first I have to pick 2 balls. First I have a total of 21, out of which if the first one has to be red, then there are 6 ways in which I can pick up this. So the probability of the first ball being red is 6 by 21. Now as I'm not replacing the balls, there are only 20 left in the bag, and as I've already picked one red, I have got 5 chances of picking the second red ball. So 6 into 5, the whole divided by 21 into 20 is the probability that both the balls are red. A slight variation on the question is, if there are 6 red, 7 blue and 8 green balls, then what are the chances that if the 2 balls are picked one after the another without replacement after being mixed up in the bag, then one of the balls turns to be red and the other blue, which means I have to select 2 balls. There are 21 total, out of which I assume that the first ball picked is red, which means the chances of getting the first ball red is 6 by 21, 20 balls left, and if the second one has to be blue, I have got 7 blue to pick from. However, the example does not end here. This is the case when the first ball happens to be red and the second ball happens to be blue. We also have the probability where the first ball happens to be blue and the second ball turns out to be red. So in this case, the probability that the first is blue is 7 out of 21 and the probability that the second is red is 6 out of 20. So I add both these probabilities to get the actual answer. It is not specified in what order the balls are being picked. So we have to consider both the cases where the first is red and the second is blue, or the first is blue and the second one is red. So let's have a quick recap of what we have seen so far. We have understood that probability is nothing but the chance of occurrence of an event. The basic formula says that the probability of an event is the number of favorable outcomes divided by the total number of possible outcomes. We have seen the questions based on coins, where we have to assume that the only 2 outcomes possible in a single coin is either heads or tails. We have seen questions on dice, where every die has 6 possible outcomes. We have seen questions on cards, where a standard deck of playing cards has 52 different outcomes possible. And finally, we saw how to solve questions on picking of balls. This was a session on probability in mathematics. My name is N. Satyanarayan. Wish you all the best. Have a good day.